Hello, I'm Dr. Ron Eaglin coming to you from Daytona State College, and this is CEN 3722, Human-Computer Interaction, and today we're going to talk about task analysis. So what we've been talking about so far in human-computer interaction is the user. Well, now we're going to talk a little bit about the task. So as a designer, you're going to really have to understand two things to create a design. You're going to have to understand the user that's going to use the design, and you're going to have to understand the tasks that have to be performed as part of the design. So what we're going to do is we're going to look at how do you get an understanding of this task, and also understanding when you perform a task, there's an end state that you want to be in, that goal. And how do we actually take the task, the concept of what needs to be done, document it, and create scenarios, and create things that are useful to you in the design process. This is also part of the documentation process. So let's first look at the concept of what is task analysis. So the standard definition of task analysis is just really knowing how people do something. And to get down to it, that is it. You understanding how somebody does something that they do, how they perform their job, or how they get something done. Now, in the field of HCI, we go a little bit deeper because we've got to go a little bit deeper. We've got to understand the cognition and the process itself. In a task, you're trying to achieve a goal. As part of the task, we're going to perform different individual steps. But it's going to be a user that performs that individual steps. But that user has to understand how those steps go. So the user has to have the knowledge and has to learn how that works. So all of those, everything I just said, is simply understanding of task analysis. But it's understanding it at a deeper and a deeper level. Well, for HCI, you really do need to design it at the deepest level that you possibly can. And the reason is that there's always many alternatives to understanding the task, but understanding how to design something to do the task. So let's look at how we can do this. So what are some things that we do here? Well, the basic understanding of a task is simply to sit down with somebody and talk it through. What do you do? What is the process that you go through to get this done? Well, once you've got an understanding of that, you're going to have to start thinking, where are the challenges? Where do we have difficulties? Okay, how does that task differ from person A to person B? Because you may think, two people perform the same task, they do it the same, but they may not do that. We have to look at it in the context of HCI. How am I going to design a system to perform that task? So that understanding goes to that level. Then you really get down to the concept of human performance. Can I do the task in 1 second? Can I do the task in 5 seconds? Can I do the task in a minute? Different ways of approaching a task can make it take different amounts of time. And performance is important because you're trying to design a task. Humans would like to be able to do the task quickly, but in a workplace setting, a task that takes an hour that you could have easily designed a system to make it take 10 minutes is a cost of real money and real time. You have to be able to document functional requirements. So you need to know what they are, but you need to be able to put them all together. And you've also got to control complexity and enhance learnability. Wow, that's a whole lot that you've got to do. So let's first look at the first step of task analysis, the concept of the goal and the task. When we talk about the goal, that is where you want to be. Good example that we've got right here is the concept of, I would like to have clean dishes. Okay, that's great. That is my end goal. The task is some sort of structured set of things that you do to get to that goal. So what can I do to have clean dishes? Well, I can take the easy route and I can simply use paper plates, which allows me to throw them away, and the dishes never get dirty in the first place. Remember, a solution that you have to the end goal may not always be that difficult, but it also may be something that you might have to think a little bit outside to get to. Or I could dirty the dishes up by using them, but then I wash them by hand. Or I can put them in the dishwasher. Or I can have somebody else do it for me. Or I can eat out. Okay, all those are tasks that allow you to accomplish the final end goal of having clean dishes. So, we need to be able to take tasks and analyze them. There's a lot of techniques for analyzing tasks. The first common technique, common to all engineering processes, common to almost all design processes, is the concept of decomposition. Start with the big picture. Break the big picture into smaller pictures, and break those smaller pictures into smaller pictures. Essentially, decompose the big task into smaller subtasks, which go into smaller subtasks. And eventually you reach a point where you don't need to go any smaller with the individual subtasks. But that is a very common technique for solving almost all types of problems. We're going to look a little bit at what we call entity relationship analysis. So we're going to look at the objects that you act upon and the actions that you take to act upon them. That is what we call ER, or entity relationship. And also knowledge-based techniques. What does the user know about the task or of the task to be able to perform the task? So first, looking at task decomposition. So the concept of a hierarchical relationship basically says you've got a high level something that has a hierarchy of other things underneath it. It's a bigger picture than the smaller ones underneath that. Okay, that is a technique within decomposition that allows you to easily decompose. And I think everybody is very familiar with this. If you can describe something in a hierarchy of actions, you are in essence decomposing it into the tasks and subtasks. So for example, a goal of having a clean house. The task will actually be the verb of cleaning the house. Well, that's a relatively simple example. My goal is to have a clean house. I'm going to have to clean the house. I have other ways to do this. I could hire somebody to come clean the house. But let's decompose that a little bit into individual steps. So, I have a number of tools that I'm going to have to use to do this, such as the vacuum cleaner. Okay, well, part of the task itself would be, let's get the vacuum cleaner out, plug it in, put the attachments on, and now I've got the vacuum cleaner ready to go. I've performed one task. I don't have a clean house yet, but now I can go through the other elements of the task, which are also decomposable. I will now use the vacuum cleaner to take all the dust and carpet debris from the room, an individual room, and remove it, making my house cleaner. I can do these in different orders. Okay, I have different ways of putting it all together. But what I've done is I've taken the goal, have a clean house, to become a task, clean the house, which now has its subtasks, use the vacuum cleaner, which has its own subtasks, remove the vacuum cleaner from the closet, put the correct attachments on the vacuum cleaner, put the vacuum cleaner in the correct room, and plug it into that room. Okay, I've decomposed perfectly. So this isn't that hard to do. Part of the design process is knowing how far you've got to go into this decomposition process. For me, a general rule of the decomposition process is when you get to a stage where you really have just common knowledge of how to do something, you don't need to go tremendously further. And it may be that in this case, use the vacuum cleaner is close enough, because the whole removing it from the closet to plugging it in, most people should know that. But again, you may need to go, remember, you're designing user computer interfaces, and those steps may be a little bit more complex. So you can analyze these individual tasks, okay, and really, it's not that hard. I mean, it isn't. You can diagram it. You can diagram it many different ways. You can diagram it in a hierarchical tree. You can diagram it with a standard, just flow chart, okay? You've got to be able to document the tasks. Part of the design process is documenting the steps along the route. Just as you're going to document what you know about users, you're also going to document what you know about the tasks. And that is going to assist you along in the design. So let's look at some of the details of tasks, not just any individual task, but just tasks. So we've got different ways of looking at tasks, like a fixed sequence task. Well, that's kind of self-explanatory in that that's something that you have to do A before you do B, before you do C. Okay, it's right there in a series. Okay, that's a fixed sequence. And that's a very common thing. You've got tasks that you may or may not have to do. They're optional. Okay, remember, when you're documenting these tasks, you have to say, well, you need to denote that these are optional some way. You may have tasks where event A is occurring, event B is occurring over here, but you can't have B go before A goes. Okay, and they may not even be in the same sequence. You have tasks that get repeated. They're cyclic tasks. So essentially, looking at that task analysis, you've got, and the two biggies here being the series and the parallel. This has to go A, B, C, D. These can go at the same time. Okay, these over here may have an effect on these. As you're analyzing the tasks, you need to denote how those individual steps affect the other steps and how they work with each other in the specifics of the task. So, simple way of looking at this. Now, in this case, what we're looking at is a list of all the things that occur. And this is a technique. You may not know the sequences. You may not know the parallels in the series. But you may be able to sit down and list everything that actually has to be done. That's going to help you get to the level of documentation that you need. There are course lists and specific lists. Course is not a list of courses. This is just looking at it from a higher level. Okay? Specific is getting down to a more detailed level. Okay? And you do want a way of notating the level that that's at. Okay, that this is just a big overview. So, hierarchical task analysis, that's, by the way, what HTA is. So, you take the list. If you're going to go that route, create the list, take the list, put it together, create a scenario of the task itself, and document that scenario. Document it in a hierarchy, okay, document it in a flow chart, and now that we've got that task laid out in something that we can look at, and what I mean by we can look at is exactly that. You're documenting for the purpose of not just yourself. Documentation has to be readable from other people. You create the scenario. Once you've got this, it should be what you need to design the system. An understanding of the user, an understanding of the task, and now it's design time. Let's talk a little bit more about task scenarios though first, because I like to use task scenarios. I like to use case scenarios is what I call them in most of computer programming. And what it is it's really looking at a situation, actually, how is the user using the system? Or how is the user going about a task? Or what is even the context in which this task occurs? So this is going to tell you some information about the users and the user's handling of the task. It may not get into a tremendous amount of detail, but we would like to get into as much detail as possible. It can be both independent of how your design is going to work or specific to how your design is going to work, okay? Doesn't really matter. At the high level, you'd like to be design independent. And as you get closer and closer to a final product, you'd like to be more design specific. Because understanding of the task at the higher level before you get into the specifics of the design is going to allow you to exercise some creativity in the design, but also, most important, it's going to allow you to spot options that you might have seen if you were immediately getting into the specifics. Let me tell you, designers will come to me all the time and say, this is how I want the thing to work. I want them to go to A, I want them to fill out this box, I want them to check this, and they already have specified the way that the whole design works. Without going back a few steps, and I will take them back a few steps and say, you know, what if we did this instead? It'd be a lot easier for the users. Let's not get into those specifics just yet. We will get into them, but let's look at what they're really trying to accomplish. So let's just actually take this. Let's take a scenario. Let's look at how a task is going to be performed. So for example, I'm going to kind of leave an example up here for you a second so you can actually read through it. We'll go ahead and cut to the slide. I'm not going to read this, but let me tell you, this is just a specific scenario of a travel agent. They're talking to their user. In this case, we're not designing we're just going to want to design a system for our travel agent to do this. This is our goal, but we're looking at what their job entails. So this is just a traditional, I'm a travel agent, and this is something I do. I've got this family, the McBrides, they've got some kids, they've got a dog, they want to fly somewhere, they want to pick up their car, they want it all to be convenient, okay? So I've written all this down as a scenario. Now, I want to take that and make it into something usable for me to design a system for my travel agent, Susan, to be able to use to help with this. So I'm going to go one step further. I'm going to start looking at the details of what we need to know. So let's look at this. One of the things that she has to do, she has to arrange for airline tickets. That tells me a very good specific of something that Susan needs to be able to do. She needs to be able to reserve a rental car. Now, she's got a situation where she knows that the family has 2 adults, 2 children, and a dog. Well, what does this mean to you in design? If you are designing a system to reserve airline tickets, the children, the adults, might be relatively straightforward. 4 tickets. But if the system doesn't allow you to specify a pet, you got a problem, okay? Same thing with the car. But you got to go one step further. They're going to get off the plane. Are they going to have a dog carrier? Okay, luggage. Okay, how much luggage are they going to have? All that is something that's important because now we're reserving a car for 4 people, a dog carrier, and luggage. Am I going to have a system, or I might know, Susan's a travel agent. She should know how big of a car that they're going to need, but she should have a system that allows her to specify that. Okay, as you see, as you move through each of the individual pieces of this scenario, you can see things that need to be included in that design. So, we can decompose this into the things that need to be done. We can look at the things, the parameters that are important to us. So for example, a system that allows us to just specify airline tickets, but not to compare prices of airline tickets, might not be tremendously useful. Okay, we want to get the best price, but we want to get the best price all the way along the way. But we also want to have the ability to specify all the parameters that we need to fulfill this scenario. Okay, again, hopefully this helps you out in looking at, I can take a scenario, I can understand the tasks that need to be performed, I can understand the constraints that go with those tasks, I can understand the effects on the users. So, create the scenario, document it completely, but focus on the critical tasks that you've got to put into the functionality of the system and all the parameters that go with that. Compose it into an actual workflow. Back with the example of Susan, she has a number of tasks that she has to perform. Airline tickets, the rental car, the hotel. A system that makes her go a different place for each of those tasks is not a good consolidated system. Something allows her to do it all at once. And I'm pretty sure that almost most people that are watching this video have used some of the great, the sites out there, Priceline or Expedia, or the online systems, which have now pretty much replaced most of the travel agents. We used to have people do all that for us. There was a reason why people did all that for us, is because it took a tremendous amount of expertise to do it. Now, the expertise has been rolled into the user interfaces of the top systems. But the people who wrote those systems built systems to replace a portion of the market. And they did that by a good understanding of the tasks and the users. So they've been able to replace out an entire segment of the workforce, travel agents, with these types of systems. And I would have to assume that most of us would like to be able to design systems that can do that type of thing too, because it's just a natural progression of how technology moves up and makes things easier to do. But it boils down to that easier to do really boiled down to the capabilities of the technology and the ability of the designers of those systems to understand the tasks that needed to be done and how that affected their users, which allowed them to replace out the travel agents. All that just rolled up into that one example. So, I know that was a tremendous amount of material to digest in that whole concept of task analysis. And we're going to have lots of different types of ways to do task analysis. But the bottom line is a true understanding of the task and understanding how to document and put it all together. Understanding the concept of a goal and a task that's going to get you to that goal, the ability to create scenarios, the ability to use those scenarios to create usable documentation, and usable documentation that can allow you to create a design and an interface to meet the specific individual needs of your users. So, we understand the user, we understand the task, then we design, and we're going to have something that's going to be tremendously successful, right? Signing out from Daytona State College, this is Dr. Ron Eaglin. Thank you very much.